Hello class, welcome back to my video with me Miss Devi. So in this video, we are going to learn about two topics. They are volume change and also the application of 3D shapes. So for the first, let me learn together about the volume change. Now we will learn together about the volume change of the radius. So if I have a cylinder here with the height 10 cm and with the radius 1 cm, let's find together the volume of the cylinder. As you know, the volume of the cylinder is P times R squared times height, and we can get the volume of the cylinder is equal with 10 P centimeter cubes. And then now we will try to enlarge. We'll try to enlarge the radius 2 times longer than this radius, okay? So the picture will be like this. Now we already enlarged the radius 2 times longer, so the volume of this cylinder will be P is equal to P times 2 times R1 square, which is we enlarge the previous radius, right? And then we'll get the volume 2 is equal with 40 P centimeter cubes. And now let's try again to enlarge the radius 3 times more longer than the first one. Okay, so the picture will be like this. So we'll get the volume 3 of the cylinder is equal with P times 3 times R1 square plus times H. Why? Because we enlarged the first cylinder 3 times longer for the radius, okay? And we'll get the volume is equal with 90 P centimeter cubes. As you can see, if we enlarge the radius, so the volume will be increasing. So to give you an idea, to find the pattern of the volume, I will show you a table. So look at this table. As you know, if we change the radius, of course, the volume will be changed, right? So we just leave the height 10 cm and we just try to change all the radius. So if I have a radius 1 cm, so the volume will be 10 P centimeter cubes, right? Because we got it before. And if I change the radius to centimeter, so the volume will be 40P, which is 4 times bigger from the first volume. And then if we enlarge again, 3 times bigger, which is 3 centimeter, so we'll get the volume is equal with 90P centimeter cubes, which is 9 times the first volume. And if we enlarge it again and again into K centimeter, so we'll get the volume K is equal with K squared times 10P centimeter cubed, which is to find the volume K, we can multiply K squared times the first volume. This is how to find the volume change. So from the table, we can find out together. If we change the radius of the cylinder, of course, the volume will be changed into K squared times the first volume. Now we can prove it mathematically as well. If I have a cylinder here with the radius R1 and I enlarge with the radius K times longer. So for the first cylinder, you can find the volume P times R1 square times H. And then let's find the volume of the second cylinder. So V2, we name it as V2, is equal with V because we enlarged the radius K times longer. So we can change the radius into K times R1 square. K times R1 square times height, because they have the same height, right? And then we can do a calculation. P times k squared times r1 squared times h. Okay, before we already have phi times r1 squared times h as phi1, and also in phi2 we got the same, right? And then we can do substitution, phi r1 squared and h into phi1. So the volume of the second cylinder is equal with k2 times volume 1. It's proved. And now, what if we enlarge the radius and the height in the same time? Okay, we'll try to find out the ratio between the volume of the first cylinder and the second cylinder. Okay, I have the cylinder here. Yeah, we enlarge the radius and also the height at the same time. Let's find the ratio. Okay, so to find the ratio, we have to do phi1 out of phi2, and we have to find the volume of this cylinder. Okay, this is for the phi1 phi times r1 squared times h. And then because we enlarge the radius of the second cylinder into k times longer, and the height also m times higher, so you can do a substitution. Okay, times m times h1. Then we can do a substitution, we can do a calculation as well, and then we can do a simplification. Then later we will get the final ratio is equal with 1 out of k squared times f. So this is the ratio of the first and the second cylinder if we enlarge the radius and also the height. Okay, to give you an idea, let's do an exercise together. Okay, by the way, the formula before, it's also can be used for the other curved solid shape like cone and also sphere. So look at this exercise. If I have a question, a cone has a radius 6 cm and a height 7 cm. If you resize the radius with the factor scale 3 and the height with the factor scale 1 out of 3, find the difference between initial volume and the final volume. Okay, let's draw the illustration. This is for the first cone before we enlarge it with the radius 6 and with the height 7 cm. And then we resize it. Yeah, for the radius we enlarge 3 times longer than the previous radius. Okay, so it's supposed to be more longer for the radius. The radius will be 3 times bigger or longer than the previous one, which is 6 cm. And then for the height, it's more lower, yeah, because we're reducing the height with the factor scale 1 out of 3. 1 out of 3 of 7. Okay, and then how to find the difference? Yeah, so there are two ways to find the difference of the volume. Yeah, we have to subtract the second volume with the first volume. So let's find using the first formula, the first way. Super easy, you can find the volume of each cylinder because we already know, yeah, all the components like radius and also height, right? So for the first cylinder, we got the volume 264 centimeter cubes, and for the second cylinder, we can also find the volume. Okay, we got 792 centimeter cubes. And then to find the difference, we can subtract the second volume and the first volume, and we will get 792 minus 264, and it's equal with 528 centimeter cubes. So this is the difference. And then for the other way to find the difference, we can apply the previous formula of the ratio of the volume. Okay, before we found the formula, the ratio phi1 out of phi2 is equal 1 out of k2 times m. Yeah, because we already know the value of k and also m. Yeah, for 3 here is the value of k, because it will be show how many times of the radius change, and also m 1 out of 3, and we can do substitution 1 out of 3 squared times 1 out of 3, and later we will get the ratio 1 out of 3. So to find the second formula, we have to multiply the first volume, sorry, not formula, I mean volume, with 3. So it's super easy to find the volume 1 is equal with 264 centimeter cubes, and we got volume 2 is equal with 792 centimeter cubes, and then we can find the difference, we can subtract, and we'll get the same value, which is 528 centimeter cubes. Now let's move on to the combined shape. So look at this shape. This shape is the combination between two curved solid shapes, right? There are cone and also cylinder. So how to find the volume total of the shape? So because this shape is the combination between two curved solid shapes, so we just need to add the volume of cylinder with the volume of the cone. And because you already know about the formula of volume of a cylinder and also volume of a cone, you just need to do a substitution, and then you can do a factorization, and then we'll get the final volume total. Super easy. And also to find the surface area is also easy, yeah, because this shape is formed by the area of a base, and also the area of a curved surface of a cylinder, and also the area of a curved surface of a cone. And because you already know about all the formula, and then you can do a substitution, and then you will get the final formula of the surface area of the shape. Okay, and later you will get the formula is equal with phi times r multiply with r plus 2h plus s. And also it's super easy to the other shape. So that's all for our lesson today. I hope you enjoy. See you on the next coming video. Goodbye.